Good morning, class. Actually, it's what's up, math scholars? You forgot my tagline. But yeah, we are on a field trip in Mrs. Talarchek's class again today. So we're looking at this big, beautiful display on the smartboard. It's so nice. Who's excited that this is our last full week of school before Thanksgiving break? We will blink and it will be Turkey Day. So today is 3-2, day 2. If you want even better news, we only have 3 more lessons to learn. This one, and then 3-1, day 1, and then 3-1, day 2. And they'll just be review and quiz, and Turkey Day will be here. All right, so today we are going to be adding and subtracting radical expressions that have the same index and radicand. Those are big words, but basically you need to make sure your little jail guards match and the insides match. So if you see these are both 4th roots and these are both 10s, you're ready to rock. These are like terms, and we would be allowed to add them. Now here's how I think about it. I remind myself that there's actually a 1 right here. And I think if I have 1 apple and I'm adding on 7 apples, how many apples would I have? Now you guys are like, silly Mrs. Harp, these aren't apples. Well, it's a similar thing. They're like terms. If I have 1 4th root of 10 and I get 7 more 4th roots of 10, I'll have 8 4th roots of 10. So I use that silly apple analogy just to make you realize you don't really need to change the 10 at all. You just keep it 4th root of 10. Okay. Wait 1 second. Okay. All right, this next one, the book actually kind of gave it away. They've got that 54 in red. I'm thinking it's in red because it's really saying to you, these aren't like terms. We've got the cube root of 54 subtracting off the cube root of 2. I like to put a little 1 there so I can think about how many I have. So I have 1 cube root of 2. But yeah, let's work on simplifying that 54 down so maybe we can get like terms. It's a cube root, so we want to simplify such that 1 is a perfect cube. Okay. So let's break 54 down so that 1 is a perfect cube. Is 27 on your perfect cube list? Sure is. Yeah. So cube root of 27 times the cube root of 2. All right, so anyways, the cube root of 27 is 3. And then so we've got 3 times the cube root of 2 for that first term. Subtract off 1 cube root of 2. That's what was up there from earlier. And now you're ready to rock and roll. You have like terms. If I have 3 apples and I subtract off 1 apple, how many apples would I have? But we're not really dealing with apples, are we? We're dealing with cubed roots. So my final answer is 2 times the cube root of 2. I had 3 cube roots of 2. I subtracted off 1 cube root of 2. Now I have 2 cube roots of 2. Good, good? All right. Oh, it double-clicked on me. All right, let's try number 6. Now, we're not adding or subtracting anymore, so having like terms is suddenly not all that important. What's important now is that these 2 jail guard guys, these 2 4s match. And when they do match, you can utilize the product property of radicals. The product property says that the 27 and 3 can go under the same jail together. Can you guys type that in for me? 27 times 3. See what we get. 81. Now, is 81 a perfect 4th root? Sure is. It's up there on our list. So what is the 4th root of 81? 3. Yeah, it technically is plus or minus 3. Thanks. Almost forgot. Math scholar right there. And then heading over to number 7, same deal, it's quotient property this time. We are lucky that these are both cube roots, so we can do the, put the 250 and the 2 underneath the same radical together. What is 250 divided by 2? Now is 120 a perfect cube? Did we look out? We sure did. 125 is a perfect cube, and our answer is 5. All right, we're moving right along, and now we're going to be simplifying radicals down that are filled with variables. Whoa. So I have a really cool trick to show you that can help you simplify these radicals down. But I have a question first, and that is, what is the jail guard that's hiding out right here? Not a 3. A 2. If they don't have a jail guard, it's a square root. So it's a baby 2 right there. So here is the little trick I'm going to show you. Do you guys remember long division? Most people are like, groan, we didn't like that. Well, it's not too bad. What you're going to do is you're going to do long division with 3 divided by 2. So 3 divided by 2 is 1. 1 times 2 is 2. And that makes my remainder a 1. So basically 3 divided by 2 is 1 remainder 1. You're wondering, where is Harp going with this? Here is what that helped you figure out. That helped you figure out how many x's got out of jail and how many x's remain in jail. The remainder is how many remain in, and the quotient is how many get out. And that's the answer. Now you don't need the 1, so most people would probably just write it x radical x. But that's basically the answer. I'm going to show you with the breaking guys from jail method how that actually does end up working. So x to the third basically is x times x times x. Do you agree? Which the breaking guys from jail method would mean circle the group of 2, have them break out of jail, have one fall in the hole, and then one got out and one stayed in. So you see how it mathematically works? Using that long division just mathematically calculates how many you can get out of jail and how many stay in. Okay, we're going to try another one. Now you can only do this with variables and exponents. All right, let's try this y to the 10th. So there is a little baby 2 right here. And then you can do 10 divided by 2. What is 10 divided by 2? 5 with a remainder of 0. So that means 5 y's are going to get out of jail and none are going to stay in. But you don't want to write it 5y. You want to write it y to the 5th. That's how that one would be written. Okay? All right, our next one has 2 variables. So we have 2 rounds of division to perform. We still have a square root, though. What is 2 divided by 2? 1 is their remainder? Nope, so 1x will get out. What is 9 divided by 2? I might need to write that one. 9 divided by 2 would be 4 with the remainder of 1. So the way we're going to write that is 4 y's get out, 1 y remains in. And again, those 1's don't have to be there. They could be absolutely invisible. That would be fine.
Thanks, Friday.
All right, we're going to try this one all by yourself. If you're watching the video at home, hit pause, and then we'll check it. Hey, people on the video, we just realized those h's could be combined, which was wild. Normally, they would have had those combined already, so that's probably just a typo of mine. You're stumped. All right, well, let's start with our g's. I always like to make an empty radical just so I can start putting people out front and I can start putting people in. Don't forget about the little 3 there that tells you it is a cube root. All right, let's start with our g's. What is 9 divided by 3? 3 with the remainder of 0. So 3 g's get out front, no g's remain in. That's what that means. Okay? Let's deal with our h's. For our h's, we're going to do 13 divided by 3. What's 13 divided by 3? 4 remainder 1, I heard somebody say. So it means 4 h's get out front, 1 h remains in. And that 1 could be invisible if you wanted to. So what were you stumped on, your g's or your h's? All right, this one's next. Now we have numbers and variables. Ooh, so I guess the biggest mistake is don't do 80 divided by 4. That would be a terrible, terrible, terrible mistake. 80 is not an exponent, so you cannot do your remainder trick on the 80. What you want to do with the 80 is what we did on Friday. You want to break it down into 2 numbers such that 1 is a perfect 4th root. I heard somebody whisper 16. That's correct. 16 times what is 80? 16 times 5 is 80. Let me go ahead and make my empty radical sign so I can start filling things in. The 4th root of 16 is 2. That will go up front. The 4th root of 5 cannot be simplified anymore. That means the 5 will go inside. Does that make sense what we've done so far? All right, let's deal with our z's. To deal with our z's, we will take the exponent that z has, the 5, and do our long division. What's 5 divided by 4? 1 with a remainder of 1. So 1z gets out front, 1z stays inside. And now we're going to do our g's. What is 3 divided by 4? Nothing. You can't really do 3 divided by 4. You can't. Basically, there's not enough g's to break from jail. That's what I'm going to conclude. So basically, all 3 g's just stay in jail. And this is your final answer. How about you say we do one more together and one as your graduation problem? Sound good?
Sounds like a plan.
Nice. All right. Pause. Alrighty, we're doing this one together. Let's talk about that negative 27 first. I do not have any negative numbers on my perfect cube or perfect fifth, but it is possible for a negative number to be a perfect cube root or perfect fifth root or perfect seventh root. What do you guys think about negative 27? Is it a perfect cube root? Sure is. If you don't believe me, let's type it in. Everybody type it in real quick. Cube root of negative 27. Before I even start, I'm going to make myself an empty cube root. It's just a good idea. What is it? Yeah, and if that works, think about it. Negative 3 times negative 3 is positive 9, times another negative 3 would be negative 27, so it does work. All right, let's do long division for our x's. Those are exponents. 9 divided by 3, what would that be?
3.
With a remainder of? Good. So 3 remainder 0 means 3 x's get out of jail. No x's remain in jail. And then what about 11 divided by 3? Also 3, but I think we're going to have a remainder. 3 remainder 2. So 3 y's get out of jail. 2 remain in. Alrighty, here's your graduation problem. So if you're watching at home, hit pause and then we'll check it in a few minutes. Alright, so we did discuss this is a square root, so we want to break that 125 down such that 1 is a perfect square. Did you guys use 25 and 2? Yeah, nobody's really saying anything. So the square root of 25 is 5, that'll go out front. The square root of 2 means the 2 will stay in jail. That's what we know so far.
Isn't it 25 is 5?
Yeah.
Oh, oopsies, thank you.
Silly goose.
Oh, silly goose. Gosh darn it, we're on the video. Sorry, people on the video, I'm having a moment. Clearly, Mrs. Harp is not going to graduate, and she's going to flunk out, but hey, it's okay. Let's do our y's. What is 8 divided by 2? 4 with the remainder of 0, right? So 4 y's get out, none remain in. Let's do our t's. What is 2 divided by 2? 1 with the remainder of 0. So 1 t gets out, none remain in. And let's do our a's. 9 divided by 2. 9 divided by 2 is 4 with the remainder of 1. So 4 a's are going to get out. Almost out of space here. And 1's going to remain in. Now I don't need to put my 2 here in my jail. But if it was a 3 or a 4, I would definitely need to denote what type of radical it was. Whew, that was a lot of work. Who graduated though? Let's see how our class did. Pretty good, pretty good. All right, so your homework, I'm going to pass it out. And if you're at home right now, it is on Polaris in the worksheet folder. The front, do all of them, and the back, just the odds. Thanks for watching our video.